Okay, so let's start by talking about how memory might actually be implemented in the human mind. Perhaps a sort of the landmark understanding of how memory might work is typically known as Atkinson and Shiffrin's modal model, also sometimes referred to as the information processing model. After all, this was conceived in 1968. So it was really created in an era of computer science, and it does make an analogy of our, it does make an analogy of information processing and the human mind and memory in particular. So for this reason, you can think of the modal model as made of repositories of information, each of which might have different properties, say in terms of how much information can be stored in it, for how long you can maintain information in it, and the format within which you can encode information in each of these repositories. And then it's about how information can flow and is directed in and out each of these repositories. Overall, this model portrays memory as really made of three main stores. So since some sensory input might be received, and at very first, the sensory input is maintained in a sensory memory, often referred to as a sensory register. And this, as we will see, it's able to take in an amount of information, but information typically is lost fairly quickly. And it is sensory specific, meaning there are different stores for different types of sensory information. So there might be a store for visual information, typically referred to as iconic memory, a store for auditory information known as echoic memory, and one for each of the five senses. It tends to have, as I said, a good capacity, but extremely short duration. The duration depends specifically on the sensory modality. And, it might go from, half a second in the context of vision, so the iconic memory store, all the way to 3 to 4 seconds, I guess, in the domain of acoustic memory or echoic memory. And so the memory is inside the store very briefly, the sensory register very briefly. And so some of it might be unattended. Some of this information will be unattended, and so it'll just sort of be lost. But some of the information will be attended, and that information can be passed further into short-term memory. In fact, only a small fraction of the information in the sensory register is attended to and therefore ends up in short-term memory. Now, the second store is that of short-term memory. It tends to have a much smaller, or at least it's conceived as having a much smaller capacity than sensory memory. However, the smaller capacity comes at the price of being able to maintain information for a longer time, say somewhere between 15 and 30 seconds. So as I said, just the time for me to give you, for example, a telephone number, and you to sort of keep it in mind and perhaps repeat it. So do things such as rehearsal, which helps maintenance in short-term memory. And then go dial the number. So in a sense, this is a bottleneck for information processing in the context of memory. Now here too, the information that isn't rehearsed, according to the Atkinson and Shiffrin model, the information that isn't rehearsed just tends to be lost from memory, whereas the information that is rehearsed might make it on its way into long-term memory. I should point out that the information in short-term memory is information that can be used either for further processing, say for reasoning or some decision-making, or it can be used to guide behavioral output, such as dialing a phone number that somebody might have just told you. And finally, as I said, the last store of this model is that of long-term memory. And again, only a fraction of the information that made it into short-term memory typically makes it into long-term memory. And as far as we know, there's no defined or found the limit of what is the capacity of long-term memory. And there's no known duration on the limit of something that can be stored in memory. And indeed, you might find that you have memories from very early on in your life. And if you ask older people, they will also similarly recount of episodes that they recalled from their youth. So by all intents and accounts, it does seem likely that this memory might last, might be able to last effectively a lifetime in terms of its duration. But let's look at these one at a time. Now, as we said, the sensory input first enters the sensory memory, also known as the sensory buffer or sensory register. You can think of this really much like a sensory memory trace. So it seems to take in a relatively large flow of sensory information, which then might or might not move forward and be further encoded and processed. And it is assumed that there is one subtype of sensory memory for each of the 5 major senses, so touch, taste, sight, hearing, and smell. However, the truth is that there's been a lot of research in 2 of them, iconic and echoic, and only very recently there's been work in a 3rd modality, which is haptic. So with respect to iconic memory, so this is the visual sort of memory, sensory memory for visual input. It does seem that this memory, and we will dig into it in just a moment, might last somewhere close to 250 milliseconds, maybe a little longer, but no longer than 500 milliseconds, if even that. Now, perhaps the closest experience you might have of clearly feeling, of having a vivid perception of what sensory memory trace, of what sensory memory might feel like for visual information. If you think of the light trails, and you can see an example of them right here at the top of my slide, if you take sort of those light trails seem to remain there even after the object has moved, and they seem to remain for some 200 plus milliseconds. And so, in a sense, this trail that you see is actually the representation of the stimulus in sensory memory. So that's sort of a fairly vivid example that you might have experienced. Now, echoic memory, which relates to acoustic information and the auditory system, this seems to be capable to hold quite a bit of information, in fact, quite a fairly large amount of information, and it seems to last up to 3 to 4 seconds. And I have given you the example of somebody talking to you, and you're not listening, and then telling you you're not listening to me, and somehow you might still hear, much like the case of the light traces, you might still hear the echo of those words, obviously quote unquote, still inside your ear. And so when somebody tells you you're not listening to me, you might still have access to the last 3, 4 seconds of what they said. And so if you allocate attention to that, then you can process it, and it can enter short-term memory, and you can report on it. So in this sense, it really seems like the echoic sort of sound is really somehow replayed inside our mind, inside the sensory memory store for this brief amount of time. And then, of course, as I said, if you attend to it, it sort of sticks. If you don't attend to it, it doesn't get processed further into the next step, which would be short-term memory. Now, finally, very recently, there has been some investigation of a 3rd sensory store referred to as haptic memory. And haptic memory concerns sensory information, so really the sense of touch. And it's unclear currently, well, many aspects of it are really not clear. It does seem to subserve particularly um, situations where you are going to grasp something, and when you interact with objects that are familiar to you. Um, and perhaps sort of the current data seems to indicate that this memory might at most last for a couple seconds, if that. But as I said, it's a fairly recent branch, so there really isn't as much known as much as in with respect to iconic and echoic memory. But overall, the role of the sensory buffer is really that to hold information in place within the same code within which it's received. So as I said, visual, acoustic, tactile, etc. And then this information either is just lost fairly rapidly, or if you allocate attention to it, then it can be moved for further processing in short-term memory. Now, Sperling in 1960 really founded the study of sensory memory and the sensory register in a series of very clever experiments. And in fact, not only he established the concept, but he also started looking for the boundaries of the sensory register, so how much information can be put in there, and for how long does it last. Now, the experiment goes something like this. In the first condition, known as the whole reports condition, you'd be shown a string of 12 letters, just as you see right here. And you'd be shown that string very quickly, somewhere between 50 to 500 milliseconds. So it's really a very quick flash. And then as soon as the stimulus comes off the screen, you just have to say all the letters that you remember. And so this is a really quick flash. And it turns out, on average, people tend to recall somewhere between 4 to 6 letters at most. And in fact, it's probably whatever part of the string they, by chance, focused on when the string sort of appeared and disappeared very quickly. Now, from this point of view, iconic memory doesn't store much because it stores 4 to 6 items out of 12. So that means anywhere from a third to 50% at most. However, Sperling realized that there are many other factors that might be problematic. For example, it takes long to report 12 letters. And so as you report the 12 letters, it's possible that you still have them all right there. But as you report them and it takes you time, then the letters start fading. But maybe you might have more than just the 4 or 6 you report available to you. It's just they decay while you're reporting. And so he developed a variant of this approach, which he called the partial report technique. And it goes something like this. Rather than seeing one row of letters, you now see 3 rows of letter in a matrix. And you are asked to attend to the whole matrix. And again, you're presented with this for 50 milliseconds. So it's literally a very quick flash. And your job is look at the matrix for those 50 milliseconds that is up there. And then right after the letters come off the screen, the experimenter will play a tone, either a high tone, a medium tone, or a low tone, to let you know which of the 3 rows you have to recall. So if you hear a high tone, you have to recall the top row. If you hear a medium tone, you have to recall the middle row. If you hear a low tone, then you have to report the bottom row. I think the important aspect of this experimental design is that by the time you're told which of the 3 rows you have to report, the stimulus is gone. So this means that in order for you to answer, you have to rely on your iconic memory. Right? You sort of, the stimulus is gone, so all you have is whatever trace of the stimulus is still, quote unquote, in your eyes. And then you read off from that either the first, the second, or the third row. Now, it turns out that using this variant, actually people are pretty good at reporting almost the whole line typically. And so the estimation was that using this approach is that really just about on average, 76% of the letters in that matrix actually are available to you for a brief instant. Enough that if I cue you, you can read off any of the three rows. Now, and so if you think of it from this point of view, contrary to the findings from the whole report technique, when you're using the partial report technique, which is this technique, memory actually, iconic memory, seems to be fairly capable in terms of how much information it can store. Now, the second, very clever variation that Sperling did is that he varied the distance between when the matrix would disappear from the screen and when you would hear the tone. So if you hear the tone right away, which is the condition that you're seeing here, so if there's zero delay between when the letters come off the screen and you're given the tone cueing you which of the three rows to recall, then you can recall several letters. However, if you start waiting for doing that, the number of letters you can report falls off dramatically. By the time you wait 1 second, the partial report gives you the same results as the whole report, which probably just means that by that 1 second, everything is gone, and the only thing that you have left is whichever part of the matrix you randomly focused on when it appeared, and that therefore entered your short-term memory. In fact, already by 200 milliseconds, the second bar, you're already losing information. So it does look like this store, it probably lasts somewhere around 200, 250 milliseconds. That would be more or less an average duration for iconic memory.